Hello, once again, students. Welcome back to another mathematics session. Onima Code is the name for those persons who will be joining us for the first time. Now, for today's lesson, we'll be continuing on matrices. As you would notice behind me here, that we're looking at the topic matrices, and specifically in today's class, we want to solve simultaneous equations using matrices. Now, before we actually get into solving simultaneous equation using the matrix method, there are some things that we want to look back at. Now, the last session, we actually looked at how we could calculate the inverse of a matrix. Yes, we did some matrix multiplication. Yes. So in order for us to go on now and to solve simultaneous equation using the matrix method, we want just to remind ourselves of some of those simple things. All right, so we're going to be looking at how to find the inverse of a 2 by 2 matrix, just to get ourselves warm up as it relates to solving simultaneous equation. All right, now if I should say A is equal to 3, 2, 2, and 2, and I'm asking you to find A inverse. Now remember, that's the notation for the inverse of the matrix. Now the inverse of the matrix would have been 1 over your determinant times your adjoint. Right? So that's the formula that we use to find the inverse of the matrix. Now, 1 over the determinant, remember, to find the determinant, it is the product of the leading elements minus the product of the non-leading elements. So the leading elements, remember, they are the one in your upper left and your lower right. So those are the leading elements. So I'm going to have here 3 times 2 minus 2 times 2. Now our adjoint matrix, for our adjoint, remember what we did to find our adjoint is to interchange our leading elements and then multiply the non-leading elements by -1. So we would end up with 2 and 3 here. Then I'm going to multiply that by -1, which gives me -2. This by -1, which end up giving us -2. Now we can work out this part here. So 3 times 2 is going to give us 6. Minus 2 times 2, which is 4. So 6 minus 4, that will end up giving us 2. And then we end up with 2, -2, -2, and 3. Now, if you notice here that at this point, you would notice that we have a scalar quantity here working with. And normally, what we would have done is to use the scalar quantity to multiply each element inside of our bracket. And that would give us the final answer for our inverse. However, because we're going to be using the inverse to solve simultaneous equation, I am going to ask you, students, to leave it right here. When they're going to use the inverse to solve simultaneous equations, I'm going to ask you to stop right here. Now, the reason for that is that if you're going to use the scalar quantity here to multiply what is on the inside, majority of the time, 90% of the time, it will end up giving you some fractions on the inside. Now, a lot of you students, a lot of you tend to have problems working with the fractions. Much more, working with the fractions inside of the matrix. So we're going to leave it right at this point, just when you're going to solve simultaneous equation using the matrix. Any other time, you would have gone ahead and used it to multiply what is on the inside. So there we have it. That's how we go about finding the inverse of a 2 by 2 matrix. All right, let's look at another one quickly. Now, what if you're given, say, A equal to 4, 3, 1, and 1. Now, what is it that I'm going to ask you to find now? I'm going to ask you to find 1, A inverse, and 2, A inverse times A. All right, so those are the two things that I want you to find here. Now, let's go ahead now and try to find A inverse. So the solution for part 1, A inverse is equal to 1 over the determinant times your adjoint. Good? Now, this now becomes 1 over 4 times 1 minus 3 times 1. And our adjoint now would end up giving us 1, 4, -3, and -1. Now, when I work this part out, you realize that we'll end up getting 4 minus 3. So that is going to be 1 times the adjoint, which is 1, -3, -1, and 4. Now, 1 divided by 1, student, is going to give you 1. So notice for this case, our inverse is just our adjoint matrix, basically. So very, very simple. So if you notice, we don't have any scalar quantity here working with now, because that would have just been 1, and it really don't change anything there. Now, for our next working out, we're going to now multiply A inverse, which is what we have right here, by A itself. Good? So let's start out by setting it up here. So A inverse is right down here. So this is going to give you 1, -3, -1, and 4. And we're going to now multiply by A, which is 4, 3, 1, and 1. Good? Now, remember that a couple classes ago, we have been looking at general multiplication, and we would have simplified the general multiplication in such a manner that it makes life easier for us. We are using the distributive law. All right, so here, these two, we distribute to 4, and we're also going to be distributing it to 3, while these two will be distributed to 1, and then it will be distributed to 1 again. So make life easier for us. So let's go and do our multiplication now. Now we're going to take down these two that we have here, which is 1 and -1. What did I map that onto first? We map that onto 4, so both of them must be multiplied by 4. Plus, we're taking that down, which is -3 and 4, and both of them, we map them to 1, so we multiply that by 1. Good. So if you notice here that we're now through with this column, we're now going to move over to the other column. So we're going to now bring this down again, the 1 and the -1, and we're going to now map it onto 3. Plus, we're taking down the -3 and the 4, and we're now mapping that onto 1. All right, so let's now go and work that out and see what we end up with. So this now becomes 1 times 4, it was 4, plus -3. 1 times 3 will give us 3, plus -3. -1 times 4 give us -4, plus 4. -1 times 3 give us -3, plus 4. This now is going to be equal to 4 plus negative 3, which gives us 1. 3 plus negative 3, which gives us 0. Negative 4 plus 4 gives us 0. Negative 3 plus 4 gives us 1. Now, that's your answer when you use the inverse of A to multiply A. Now, what is it that you notice here? Now, every single time you multiply a matrix by its inverse, the result is your unit matrix. And remember, we always use the capital I to represent the unit matrix or the identity matrix. Good. So when you multiply a matrix by its inverse, you end up with the identity matrix. And I am stressing it because if you understand this concept, then it makes life easier for you when you have to solve a pair of simultaneous equations using the matrix method. So again, let us say, let me remind you that every single time you multiply a matrix by its inverse, then you're expected to get the unit matrix, which is 1, 0, 0, 1. Good with that? Okay, all right? So we look at how to find the inverse. We look at the inverse multiplied by the matrix itself. What's the result? It's the unit matrix. Now, before we actually look at a question with the simultaneous equation, we're going to look at the unit matrix and see how this unit matrix operates. All right. So let us see what happens there. All right. So I'm going to clean this part. Remember, in our last session, I said to you, to get the information in a quick manner, you could just snap a pic and then later on you could rewrite the information in your books. All right. So I'm asking you to do that so we can speed up as it relates to time. Now let us see what takes place when you're using the unit matrix to multiply. Now, if I give you the unit matrix I, which is equal to 1, 0, 0, 1, and I give you a matrix B, and B is equal to 3, 5, and I ask you to say, find the matrix product IB. To find the matrix product IB. Now, the matrix product IB would be 1, 0, 0, 1 times 3 and 5. Again, using our distributive law, we're taking these two and we're distributing them to that one. These two will be distributed to that number. Now, only one column here, so the distribution will only take place once. So let's see what happens now. I'm going to take down the 1 and the 0 here. 1, 0. Now, what did we distribute 1, 0 to? We distributed to 3. So this becomes 3, 3. So you multiply both of them by 3. Plus, we're taking down the 0 and the 1. What did we distribute those two? We distributed to 5. So both of them must be multiplied by 5. Now let's go ahead now and multiply. So it's 1 times 3 will give us 3, plus 0 times 5 will give us 0. 0 times 3 will give us 0, plus 1 times 5 will give us 5. Now let's add 3 plus 0 will give us 3. 0 plus 5 will end up giving us 5. So notice here that we end up using our identity matrix to multiply the matrix B. What is the answer? The answer is B, which is 3, 5. But what is this? actually saying to us here, students. Now, before I would have mentioned to you that the identity matrix, it operates like the numeral 1. All right, remember the multiplicative identity is 1. When I use 1 to multiply any number, it does not change that number's identity, right? That's the same thing that is happening with our identity matrix. When we use the identity matrix to multiply another matrix, the identity of that matrix remains intact. And that is why when I use our identity matrix here to multiply the matrix B, we're going to end up with B. Very, very simple and straightforward. So what are the things that we need to remember now? We need to remember, one, that when you multiply a matrix by its inverse, you're always going to end up with your identity matrix. And from time to time, you will see questions on your CSEC paper where they will say to you, write down the 2 by 2 matrix, like they would say, write down the 2 by 2 matrix which B inverse B is equal to. All right, write down the 2 by 2 matrix that B inverse B is equal to. Now, what I need you to understand, students, is that majority of the time, that question only valued 1 mark. So, what is needed here? All you need to do here is to write down the identity matrix, which is 1, 0, 0, 1. Good, 1 mark. Because when you multiply a matrix by its inverse, every single time you're going to end up with your identity matrix. Good? So that's one of the things that we went through earlier. Now, the next thing that I want you to remember now is that when I use the identity matrix to multiply another matrix, the answer remains the same. So, in other words, the multiplication, the general multiplication with the identity matrix really don't change anything. So if I use the identity matrix to multiply B, then I will get back B. That's all I'm saying to you. It is like multiplying by 1. Good. Now, with that out of the way now, we're now going to go back now to look at how we can actually solve simultaneous equation using the matrix method. So our objective for today, for my fifth formers, would be solve simultaneous equations using matrices. Now, there are some steps that we need to remember when you are about to solve these equations. So, step 1, it says here, write the equations in the matrix form. Write the equations in the matrix form. Now, how do we do that? Here is a general idea of how you would set it up. So it's going to be AX equal to C, where AX and C are all matrices. AX and C are all matrices. Now, A would be the numerical coefficients of the variables. A would be the numerical coefficients of the variables, while X would be the variables, represent the variables in the matrix form. And C would have been your constant, all right, the constant terms here. Now, there's nothing so special about these letters because they could change it. They could give you a simultaneous equation and say, write it in the form AB equal to K. That simply means that you're going to write it in the matrix form. Good? Now, our next step here, it says, find the inverse of A. Find the inverse of the 2 by 2 matrix. Good? Now, notice here that to solve it, it is saying that you need to find the inverse. And now you would realize why I went and recapped how we go about find the inverse. Good. Step 3, it says use the inverse to multiply both sides of the equation. Use the inverse to multiply both sides of the equation. All right. Now, the fact that you're able to calculate the inverse or to find the inverse of a 2 by 2 matrix, you know how to multiply, general multiplication that is, then solving a pair of simultaneous equations should be very, very simple for all you students who are actually watching this program right now. So what is it that we're going to be doing now? We're going to be solving a pair of simultaneous equations using the matrix method. So let's go. Now we're going to start out with the pair of simultaneous equation 3x plus y is equal to 7 and 3x plus 2y is equal to 5. Now, there we have it. That's the pair of simultaneous equation that we're going to be solving, but we need to use the matrix method. Remember, there are many methods, well, a few methods that we can use. We can use the elimination, substitution, we can use trial and error, we can also use matrices, we can also solve these equations graphically. All right, but today we're looking at it in terms of the matrix method. Now, remember, step 1 says that we should write the equation in the matrix form. Write the equation in the matrix form. Now, remember that A represent the numerical coefficient of the variables. A represent the numerical coefficient of the variables. So when I look up here, 3 is the numerical coefficient of this x. I'm not seeing any number here in front of y, which is connected to y. But you should know that the numerical coefficient here is going to be 1. Here is 3, here is 2. So what is it that we're going to do? We're just going to take out those numbers as is and write it in the matrix form. So we're going to have to write it like this: 3, 1, 3, and 2. And that now would be the matrix A. So we take out the numerical coefficient of the variables and we write them in the matrix form. Now, point to note is that all the coefficients up there, they're all positive. And that's why inside of the bracket, we will just write them down as positive numbers. Now, if it's a case where one up there is negative, then you need to take that negative sign down into the matrix just the same. Okay? All right. Let's now write down our x. Now, remember that we said that our x matrix here is going to be our variables. The x matrix is going to be our variables. So let's write that down. Our variables that we're dealing with now would be x and y. And this is now equal to the matrix C, which is going to be our constant terms up here. The matrix C, which is going to be the constant term up there. Good? So what are the constant terms? The constant terms would have been 7 and 5. So this is now our matrix C. So 7, 5. Very good. So notice here that the pair of simultaneous equation is now written in the matrix form. AX equals to C. Now, how do we go about solving? We're going to move to step 2. It says find the inverse of A. Here is A, we need to find the inverse. So let's find the inverse. Because I know you're very good at this now, so we're going to find the inverse here. So A inverse is equal to 1 over the determinant times the adjoint. Now, let's work that out. So this becomes 1 over 3 times 2 minus 1 times 3. And my adjoint matrix now would be, we interchange. So this becomes 2, 3, and we multiply the non-leading by -1. So this becomes -1, -3. Here we have it. 3 times 2, 6. 1 times 3, 3. So if I take away 3 from 6, we have 3 remaining here. Times your adjoint, which is 2, -1, -3, and 3. Good. So there we have it. Step 2. All right. So step 1, write it in the matrix form right here. Step 2, find the inverse of A. Step 3, use the inverse of A to multiply both sides of the equation. Use the inverse of A to multiply both sides of the equation. Now, let us look at this, student, because here we have our equation here. And what we're saying now is that we should use the inverse here to multiply both sides of this equation. And if you notice here that I did not use my scalar quantity to multiply each element inside the bracket, because I'm going to have to use this matrix to do some multiplication, and I don't want to have the fractions inside there to work with just yet. Okay, so I leave it as it is right now. So our next step, step 3, we're going to use the inverse to multiply both sides of the equation. So let's see what happens. So it is going to be A inverse AX equals to A inverse C. That's what we're going to be doing now. A inverse times AX equal A inverse C. So I can just write it here. We're going to continue over that side. So I'm going to write down A inverse, which is 1/3 of 2, -1, -3, and 3 times 3, 1, 3, 2. And that is going to equal to A inverse, which is 1, 3, 2, -1, -3, and 3 times 7 and 5. That's how you would normally set it up. So you're using the inverse to multiply both sides of the equation. Using the inverse to multiply both sides of the equation. Now, let us examine what is happening here. Oh, I actually missed something. Sorry about that. Let's go again. We would end up having x, which is right here, x and y, equals to 1/3 of 2, -1, -3, and 3 times 7 and 5. So that's what we should have. Sorry about that. Now let's examine what is happening now, because we're working with time. And the fact that we're working with time, we don't want to waste our time doing unnecessary work in our exam. All right. So notice here, this is A inverse, and you're multiplying that by A. A inverse multiplied by A. But we already established that A inverse times A is always going to give us the unit matrix. Always going to give us the unit matrix. So therefore, A times A is going to give us 1, 0, 0, 1. So that's the answer for that part. Good? Now we're going to use the unit matrix now, the answer to this part, to multiply the matrix C. But again, we would have already established that the unit matrix times any matrix at all really give you back that matrix. It really don't change anything. So 1001 times x and y, the answer would be x and y. So we know what the answer for this part would work out to be. So therefore, all I need to do for this part, we're going to end up with x, y on this side. Now, students, what I'm trying to get across to you is that even though step 3 mentioned that we should multiply both sides of the equation by the inverse, the left-hand side of the equation, we know exactly what is going to be our answer for that. It is going to be the variable matrix that is on that side. Very, very simple. So all we need to do here is to work this part out. That's all we need to do. So let's go and work that out. And let's see what happens now. So this is now 1/3, 2, -1, -3, and 3 times 7 and 5. All right, so there we have it. We need to now multiply. Now this 1/3, we're not going to use it yet because we don't want to create any fractions which might create some problems for some of you. All right, so let's bring this back down. We'll bring back down the 1/3. Now again, 2 and -3 will be mapped onto 7, while -1 and 2 will be mapped onto 5. So let's see what transpires now. So we're going to take down the 2 and the -3. What did we map it to? We actually map it to 7. So both of them must be multiplied by 7. Plus. Now we're going to take down the -1 and the 3. What did we map those onto? We map them onto 5. So both of them must be multiplied by 5. We are not ready for our 1/3 just yet, so we still bring it back down. Open bracket, let's work this out now. 2 times 7 will give us 14, plus -1 times 5 give us -5. -3 times 7 will give us -21, plus 3 times 5 will give us 15. Let's bring back that 1/3. And let's work this out now. So here, 14 plus -5 will end up giving us 9. -21 plus 15 will end up giving us -6. Now, student, at this point, we now use our scalar quantity, which is the inverted determinant, to multiply each term inside the bracket there. Now, if I am multiplying by 1/3, it is the same thing as dividing by 3. Multiplying by 1/3 is the same thing as dividing by 3. So all we need to do here is to say 9 divided by 3 will give us 3. -6 divided by 3 will give us -2. So now we're saying that x and y, x is equal to 3 and y is equal to -2. So you would have now solved the pair of simultaneous equation using the matrix method. Now, let's just recap steps. Write the equation in the matrix form. That's what we did right here. Find the inverse of A. That's what we did right here. Use A inverse to multiply both sides of the equation. Now, that's what we did right here. But what we're actually saying here is that the multiplication of the left-hand side of it with the inverse is not really necessary because we know what the answer will be. So all we need to do is to multiply the constant by the inverse matrix. And that now would solve the pair of simultaneous equations. Now, we're out of time for this session. So I'm just going to ask you please to join me again when we will look at some more simultaneous equations, solve some more simultaneous equations using the matrix method. And also, we will look at a question as it relates to equal matrices. So I'm looking forward to see you in the next session.